Dear students, today's discussion is on stoichiometry, which is very important from the chemistry point of view. Okay, so first, what is stoichiometry? Stoichiometry is a branch of chemistry that deals with the relative quantities of reactants and products in chemical reactions. Means what? Whenever we write a chemical equation in balanced condition, how many moles of reactants and how many moles of products are there in that equation, they are called as stoichiometric coefficients. For example, in the case of water, it is 2H2 plus O2 gives 2H2O. Behind H2, 2 is there. Behind O2, 1 is there. Behind H2O, 2 is there. They are called 2, 1, 2 are the stoichiometric coefficients for hydrogen, oxygen and water respectively. This stoichiometry word is taken from the Greek literature because Greek literature and the Latin literature are the foundation for us. They are the pioneers in the science field. Therefore, we take the meaning from the Greek or the Latin language. So in the Greek, stoichion means element, metron means measure. That means we are measuring the element. Okay, how much element is participating in a reaction and how many elements are formed. That means on the reactant side, how many elements are there, in what mass, or in what moles, or in what volume, and after the reaction, products are formed. So how much mass of products are formed, or how many moles of formed, or in terms of volume if it is a gas. So all these quantitative relationship between the reactants and the products, how much we have taken, how much is formed, that comes under the chapter stoichiometric relations or the stoichiometric calculations. Remember, stoichiometric calculations depends on the two laws. First is the law of conservation of mass. Why? Because in the beginning we have discussed that for the stoichiometry we want a chemical equation in the balanced condition. When it is in the balanced condition, so law of conservation of mass holds good 100%. And second law what? Law of definite proportion. Because in every compound, proportion of elements is fixed. So first mass is fixed, proportion is fixed. So these two laws are very important for the stoichiometry, and this is the heart of the chemistry. Like how mole is the important concept, like that stoichiometry is also one of the important concepts in the chemistry. A small chart will tell us what is stoichiometry and in what way we calculate. See, sometimes we will calculate mole to volume or volume to the mole or mole to the mass, mass to the mole or mole to the number, number to the mole or sometimes volume to volume or sometimes mass to mass or sometimes number to number. These many number participated in the reaction and how many are formed, or this much volume of gases were there before the reaction and these many gases were formed after the reaction. Here also this much amount, this much gram of reactants were there and after forming this much amount of the products are formed. So, or in terms of mole, earlier I was having 10 moles, now how many moles are formed. So all these interconversions, okay, comes under the stoichiometry. Let us take one example. CH4, 1 mole of CH4 plus 2O2 gives CO2 and 2H2O. See the statements. 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. This is in terms of mole. You see the second statement. This is in terms of the particle. If you go at the microscopic level, only one particle participates. So if you tell in terms of particle, it is one particle. Two particles, one particle, two particles, same thing as given here. So particle is what? This is the molecule, no? So one molecule, two molecules, one molecule, two molecules. This is what? Second statement. This is he has stored in terms of moles, in terms of number. Now he will tell us in terms of volume because they are in the gaseous form. Okay. So 1 mole of any substance in terms of gas equal to 22.4 liters. Avogadro hypothesis. Okay, right. So 22.7 is here. Both are equal. So 22.7 liters of methane reacts with what? 2 moles. 2 moles what? 22.7 and 22.7 or 22.4, 22.4. Both are equal, both are accepted. So that is 2 moles. 22.7 into 2. Now, how many moles of CO2? 1 mole. 1 mole equal to once again 20.7 liters as per Avogadro. And 2 moles of water in terms of volume, gas, it is 2 into 22.7, that is equal to 45.4. So, this is in terms of volume. Now, this is in terms of mass. CH4, 1C, 12, 1, 4 hydrogen, 4 into 1, 4. So, 12 plus 4, 16. 16 gram of methane reacting with 1 O equal to 1 O equal to how much? 16. And there are 4 O. So 16 into 4, 64, or 1 O2 equal to 32, mass of one oxygen molecule. So 2 oxygen molecule weighs 32 into 2 equal to 64. So in terms of mass, 16 gram of methane reacting with 64 grams of oxygen to give 44 grams, 32 plus 12, 44 grams of carbon dioxide, and 1 water equal to 18 gram, 2 water equal to 36 gram of water. So I told the previous chart in terms of mole, in terms of number, in terms of volume, in terms of mass are interconvertible. Okay. Now this is an example. Okay. Excuse me. When carbon dioxide is formed, now what is the question here? What is the amount of CO2 that can be produced when 1 mole carbon is burnt in air? For this, first you have to write I told in the previous discussion, in the stoichiometry, balanced chemical equation is a must. So balanced chemical equation for the formation of carbon dioxide is this one. Okay. Now, when 1 mole of carbon is burnt in air, how much CO2 is formed? See, 1 mole to 1 mole. So what is 1 mole? 1 mole is 44 gram. Therefore, answer for the question number 1 is what? 44 grams of carbon dioxide is formed from the 1 mole of carbon. So it is the mole to the mass. Second, when we burn 1 mole of carbon in 16 gram of oxygen, as per the balanced chemical equation, 1 mole requires 1 mole. What is 1 mole of carbon? It is 12 gram. What is 1 mole of oxygen molecule? O2. 16 plus 16, 32. So 1 mole of carbon requires 32 gram of oxygen, but he has told 16 gram. Okay, that means half mole. For half mole, we require half only, half mole of carbon. So 1 mole of carbon equal to atomic mass of carbon 12 gram, half mole equal to 6 gram. So what is the answer? When 1 mole of carbon, that is 16 gram of carbon is burnt in 1 mole of carbon, 12 gram is burnt in the 16 gram of oxygen. How much is formed? Answer is 22 gram of carbon dioxide. Why? For the half mole, for the 1 mole, 1 mole, half mole, half mole. Okay, right. The third question is, when 2 moles of carbon are burnt in air, 2 moles of carbon, okay. For 1 mole of carbon, 1 mole of O2 are required so that 1 mole of CO2 is formed. This is as per the chemical equation. Now we are using 2 moles. For the 2 moles, we require 2 moles of O2, but he has given only 16 gram. Okay. Therefore, 16 gram requires only 1 mole of C. Therefore, how much CO2 forms? CO2 forms is same once again. It is 22 gram only. Further, problems will clarify stoichiometric calculations. How much copper can be obtained from 100 gram of copper sulfate? Okay, yeah. What is 1 mole of copper sulfate? 1 mole of copper sulfate, its molar mass. It is 159.5 gram. Now you please see. In 159.5 gram of copper sulfate, how much gram of copper is there? 63.5. Correct? So when we use 159.5 gram of copper sulfate, we get 63.5 gram of copper. But what is asked? How much copper is can be obtained from 100 gram of copper sulfate? For 100 gram, how much? So 100 into 63.5 by 159.5. That gives you 39.81 grams. Simple calculation. In 3 moles of ethane, calculate the given below. Number of moles of carbon atoms, number of moles of hydrogen atoms, number of moles of ethane. Yeah. Now, in 1 mole of ethane, how many moles of carbon? 2 moles. How many moles of hydrogen? 6 moles. Okay. Now, in 3 moles, number of moles of carbon, 3 into this 6. Similarly, number of H atoms, 3 into H, 3 6 are 18. Here is the answer. Number of molecules of ethane. Number of molecules of ethane. So one molecule, 1 mole means this. What about 3 moles? So 1 mole of ethane contains 6 moles of hydrogen atoms. Okay. Therefore, number of molecules are in 3 moles of ethane equal to 3 into this much. This in terms of Avogadro number. So these many molecules are there in 3 moles because 1 mole of ethane contains 6.023 or 22 into 10 to the power 23 molecules of ethane. 3 moles multiply. This is the answer. Second, next stoichiometric numerical. Chlorine is prepared by adding manganese dioxide with hydrochloric acid according to the following equation. 4HCl plus MnO2 gives 2H2O, MnCl2 and chlorine. Question is, how many grams of HCl react with 5 gram of manganese dioxide? Let us calculate as per the stoichiometry how much is required. 4 moles of HCl means 4 into this. This is what? This is the gram molecular mass of HCl equal to 146. So 4 HCl means it is 146 gram. Now 1 MnO2 is 1 MnO2 equal to, no need to calculate here actually. What is the question here? How many grams of HCl react with 5 gram of manganese dioxide? Okay. What is the MnO2 mass here? Mn and 2O2. That gives you here 87. 87. Okay. Here is the answer 87. Okay. Now, according to the balanced chemical equation, according to stoichiometry, 1 mole, that is 87 gram, is required to react with the 146 gram of HCl. Now, if I use 5 gram of MnO2, here is the equation and the answer is 8.4 gram of HCl. Therefore, we require 8.4 gram of HCl.